Good morning, hello, and welcome back to the channel. If you are a passionate on cybersecurity, secure coding, or application risk management, you are in the right place. In this video, we are diving into one of the most respected and practical resources in web security, the Open Web Application Security Project or OWASP Testing Guide. And we'll explore it through the lens of vulnerability management. So, what exactly is OWASP testing guide? Well, in simple terms, it's like a blueprint for ethical hackers and security testers. It shows how to test web application for weaknesses. Whether you are dealing with authentication, input validation, API flaws, or complex business logic. It's created by the Open Worldwide Application Security Project, a global community dedicated to improve software security. But here's the key takeaway. The OWASP testing guide is not just about finding bugs, but when strategically used, it becomes a powerful tool in a mature vulnerability management program. Let's break that down. In vulnerability management, we follow a cycle which is identify, detect, prioritize, remediate, and improve. The OWASP guide aligns beautifully with this. It helps us identify attack surface, detect real world vulnerability, and prioritize risk based on context. Not just CVSS score, but also business logic, abuse, and data exposure. It's especially valuable when automated scanner falls short. Logic flaws, insecure configuration, and access control issues often requiring human insight. And that's exactly where OWASP shines. In a DevSecOps world, we are no longer waiting until after deployment to test. We are bringing security left, embedding these OWASP based tests into coding, CI/CD, QA, and even production monitoring. From a compliance perspective, whether it is ISO 27001, PCI DSS, GDPR, or SOC 2, the guide provides structured testing methods that prove you are doing your due diligence. And yes, auditors just love that. But let's be honest, there are challenges too. Time constraints, skill gaps, and fragmented process can all limit how effectively OWASP testing is used. That's why it's important to automate where you can, prioritize what matters, and build collaboration between dev, security, and ops teams. To wrap up, think of OWASP testing guide not as a long checklist, but as a security conversation starter. It bridges the gap between code and risk, between developers and defenders, and between findings and real remediation. So, whether you are a student starting out, or a developer trying to secure your code, or a security leader aiming to mature your vulnerability program, this guide belongs in your toolkit. Now, if you found this valuable, don't forget to like, share, and subscribe. And stay tuned because in upcoming videos, we'll break down key OWASP phases like authentication, testing, API, security, business logic, validation with visuals, checklist, and real world insight. Thanks for watching, and remember, security isn't a sprint, it's a cycle, and OWASP gives us the map. Do note this is part 3 of the vulnerability management series. Namaskaram. This is your host Savit Vittal Salian. Let's enjoy this subject. In today's digital world, where applications form the core of business operation, attackers continuously exploit application level weaknesses to compromise systems and steal sensitive data. Vulnerability management program must go beyond infrastructure level patching and include systematic testing of web applications and APIs. This is where the OWASP testing guide plays a critical role. The Open Web Application Security Project is a non-profit foundation dedicated to improve software security. The OWASP testing guide, currently in its V4, that's version 4, and under active development towards version 5, is a globally accepted framework for performing comprehensive security assessment of web applications. From a vulnerability standpoint perspective, it provides a structured, risk based approach to identifying, assessing, and managing application vulnerability. This video explores how OWASP testing guide supports the objective of a modern vulnerability management program. It discusses the testing process, alignment with risk framework, integration with DevSecOps, and its value in the regulatory compliance and business assurance. Well, in simple language, in today's digital world, application, especially web and mobile apps, are the front doors to many organizations. But just like physical doors, these digital entry point can have hidden flaws. That's where OWASP testing guide comes in. The OWASP testing guide is globally respected playbook created by the Open Worldwide Application Security Project. It outlines how to find, test, and fix weaknesses in software application. It's done step by step. From a vulnerability management perspective, the OWASP testing guide is more than just a testing manual. It serves as a technical lens into discovering application level vulnerability like broken authentication, misconfigured security setting, or insecure APIs that traditional infrastructures may miss. This guide helps developers write more secure codes. The security tester follow a standard method to identify flaws and helps organization understand where their most exposed risk might be hiding. Well, that's inside the code itself. In the broader vulnerability management life cycle, OWASP testing helps the detect, prioritize, and respond phase by providing deep insights into applications, specific issues that could be exploited if left unresolved. This session will explore how the OWASP testing guide fits into the vulnerability management space, strengthens your overall security posture, and bridge the gap between developers, security team, and risk owners. Whether you are scanning codes or reviewing controls, the OWASP testing guide is a vital tool for finding what's broken before the attackers do. Let's now try to understand the testing guide. So, what is OWASP testing guide? Well, the OWS testing guide is a manual that outlines techniques, for testing web applications for security weaknesses. It is organized in several key testing areas and includes specific test cases for identifying known vulnerabilities like SQL injection, cross site scripting, and broken authentication, and more. In simple language, the OWASP testing guide is a step-by-step manual that helps security professional test web application for their weaknesses or if there are any. It was created by OWASP, the Open Worldwide Application Security Project, a global non-profit that helps make software more secure. What the guide does? Well, it explains how to find security flaws in websites and web applications. It shows where to look, what to test, and how to test it. It covers everything from logging systems to database interaction and API security. Well, who uses it? Well, used by a security tester or ethical hacker, if you want to put it that way. Developers who want to check their own codes. Organizations looking to improve their application security. Now, why it's important? Well, many attacks happen because of common coding mistakes. The guide helps team to catch these issues early on before attackers find them to create a standard approach. So security testing is repeatable and reliable. In one line, if you put it up, the OWASP testing guide is like a checklist and instruction manual that helps you test web application for security problem before attackers can exploit them. Now let's move on to core structure of the testing guide. Well, the guide follows a structured approach. Starts with steps as shown in the screen, and each category provides test objective, test cases, execution step, and tools to use. In simple language, the OWASP testing guide is designed to help security professionals test web applications in a systematic and organized way. It breaks down testing into phases and categories, so nothing is missed. Here's how the guide is structured. Well, this part, the testing framework overview, if I put it up that way, this part explains the purpose, scope, and philosophy of the guide, which is why we need to test, when to test, whether during design, development, deployment, who should be involved, whether the developer, tester, security team, or how it fits into the SDLC, that's the software development lifecycle. It sets the stage for how to think about testing. Well, it starts with information gathering. This is the first phase of testing, like recon in a cybersecurity. It covers collecting public info about the application, tools and methods to map the web application structure. It helps understand what the app does and how it really works. The thought process is before you can find a flaw, you need to know what's there. The next is threat modeling. Now, what's that? Well, this part helps you understand what are the most valuable assets. What are the likely threats? How might an attacker try to break in? The thought process at this is it's about thinking like a hacker before testing like one. Then the testing criteria, the main section, which is authentication, is wherein we test is the login process secure. Session management, can an attacker hijack or fake sessions? Authorization, can a user access only what they are supposed to? Input validation. Can user inject harmful code like SQL injection? Configuration management. Are the app and server set up securely? Error handling. Does the app reveal too much when it crashes? Cryptography. Are encryption and data protection done right? Business logic. Can user break the app's rules or logic? API testing. Are the app's API secured? Client side testing. Are JavaScript and browser based controls safe? Well, each category includes what to test, how to test, why it matters, example tools or commands. The thought process here is these sections provide real world hands on testing instruction. The next is reporting. This part explains how to document your finding, how to explain risk to developers and manager, how to prioritize fixes. A good test means little if no one understands the results, isn't it? In summary, the OWASP testing guide is built like a map and manual. It takes you from planning and discovery through hands-on testing and ends with reporting and fixing what matters. Vulnerability management and web application security. Well, in simple language, in today's connected world, web applications are often the first place attackers target. They are always online. They handle sensitive data and can have many hidden flaws. That's why vulnerability management and web application security must work together, and that's exactly what OWASP plays a key role. That's where it plays the role. What is web application security? Well, it's about protecting website and online apps from attacks. It includes stopping hackers from stealing data, making sure users can only do what they are supposed to, fixing coding mistakes before someone exploits them. Now, where does vulnerability management comes in? Well, vulnerability management is the process of finding the weakness, prioritizing the risk, fixing the problem, tracking and improving over time. For web apps, this means scanning the app for security bugs, testing logging pages, APIs, forms, and backend logics, fixing things like SQL injection, cross-site scripting, or broken authentication. Now, how does OWASP helps? Well, it provides first testing guide, which is a practical step-by-step manual to test web apps. The top 10, which is a list of most critical web security risks. The application security verification standards or ASVS. A detailed checklist for secure coding. These resources helps you to understand what to look for in your application. Perform technical testing as part of the vulnerability lifecycle. Align developers, testers, and security team on a shared standard. Vulnerability management plus OWASP equals to smarter security. From a phase perspective, if you remember the earlier video on the vulnerability management phases, we had identify, detect, prioritize, remediate, and improve. The equivalent, the OWASP contributes in identify, it uses OWASP top 10 to recognize the common risk. With detect, use the testing guide to find real weakness. From prioritization perspective, it maps flaws to business impact and the OWASP risk rating. When it comes to remediate, it follows secure coding practices recommended by OWASP. From an improve phase perspective, use OWASP checklists and tools for repeatable, scalable security. In summary, OWASP helps make web applications stronger and safer by giving you the tools to find and fix vulnerability, while vulnerability management ensures nothing falls through the crack. Do remember this. OWASP gives you the tool to find and fix the vulnerabilities. That's the key here. Together, they form a powerful combination to protect organization from modern threats. I hope this helped with the initial context. Let's look at phases of OWASP testing guide from a VM lifecycle lens. We have three in this, starting off with information gathering, configuration and deployment management testing, identity and authentication testing, followed by authorization and session testing, input validation, and so on. Let's go through each of them in detail. Information gathering. Well, simple language, the information gathering phase is the first and one of the most important step in web application security testing. Think of it like this. Before security testers or attackers can find vulnerability, they first need to be understood how the application or understand how the application works, what it's made of, how it behaves, and what parts are visible from outside. It's a process of collecting all the technical details about a web application before doing a deep security testing, which includes the technology being used, whether it is WordPress, PHP, JavaScript framework, etc. The server type, what is it? Apache or IIS, etc. The domain names, subdomain names, IP addresses, public file, directories, APIs, login pages, third-party services or libraries in use. That's information gathering. The common techniques used in this is DNS enumeration, which is finding related domains and IPs. Doing a whois lookup, that is getting ownership and registration information. Port scanning, checking for open ports that may expose services. Banner grabbing reveals server and software details. Spidering, crawling, automatically mapping all links and pages. Directory brute force, which is finding hidden files or folders. Or search engine dorking, that is use Google to find exposed data. This is the common techniques used. Now, why is this important? Well, because you can't secure what you don't understand. Information gathering helps testers map the attack surface. All the parts of the app that can be tested are done here. Understand how an attacker might approach the system. Prepare for more focused testing in later phases. From a vulnerability management perspective, this phase ensures nothing is missed, like forgotten APIs, hidden admin panel, or old pages still live. It helps security team build better asset inventories, which is a key part of the identify function of the NIST CSF. In summary, the information gathering phase is like surveying a building before checking for weak spots. It gives tester a clear view of the application's structure, technology, and entry points, setting the stage for a deeper, smarter vulnerability testing. The next pillar is configuration and deployment management testing. Well, in this phase focuses on finding security mistakes made during the setting up of or during deployment of web applications or server. Think of it like this. Even if the code is secure, the way it is set up can accidentally leave doors open for attacker. So what does this phase test? Well, it looks for if whether the server is running unnecessary services, default passwords or settings are still used. It looks for sensitive files if they are exposed. It looks at the application shows any debug messages or stack traces. Looks for configuration files revealing any internal logics or credentials. Any old or outdated versions of software if they are in use. Directory listings are enabled, showing the file structure to outsiders. Well, the common issues found are first, exposed config or backup files. Now, if this is the case, it may contain passwords, secrets, or internal logics. That's a risk. The next issue, which is potentially default admin panels or ports. Why it is risky? Well, attackers can easily find and exploit them. The next issue is misconfigured error pages. If it is, it can leak details about the application or servers. The next issue is outdated software versions. If they are, it may have known exploitable vulnerabilities. Next issue is unused services are still running. If that's the case, it increases the attack surface unnecessarily. One of the issues also is directory listings are enabled. If that is the case, it shows internal structure and file names to attackers. So why it matters in security testing? Well, misconfigurations are one of the most common cause of security breaches. Even strong, well-tested application can be vulnerable if debug mode is left on, deployment tools aren't locked down, and test environments are accessible from the internet. From a vulnerability management perspective or VM perspective, these issues may not show up in a standard app vulnerability scan, but they can be just as dangerous. Fixing them often require good process, not just patches. It supports the protect and the detect phase of NIST CSF, if you remember that, by ensuring the systems are configured properly and monitored. In summary, the configuration and deployment testing phase checks how the app and its servers are set up to make sure no mistake leaves the system open to attack. It helps catch real world missteps that's often led to breaches even when the code itself is secure. The next one is identity and authentication testing. Well, the identity and authentication testing phase focuses on how user logs in to an application, how their identities are verified, and whether that process can be tricked, bypassed, or broken. In simple terms, this phase checks if the login system is safe and whether users' identities can be faked, stolen, or guessed. So what does this phase do? Well, it tests whether the login process is secure, whether the passwords are stored and protected correctly, whether user can bypass authentication using tricks like SQL injection, the multi-factor authentication is present and working. It tests whether login forms are protected from brute force attack. It also tests session tokens if they are strong and not guessable. It tests whether forgotten password and account recovery features are secured. So that is what this phase does and tests. During this phase, the common vulnerabilities that are checked are weakness or guessable password. The risk is if it is, attackers can break into the account. They check for missing rate limits on logins. If there is, it allows brute force attack. It checks for poor session management. If it is, attackers can hijack user sessions. It tests for insecure password reset process. If it is, attacker can take over the account via email or SMS. It checks for MFA bypass or not enforced. If it is, it weakens the secondary layer of defense. It also checks for default credentials if they are still in use. If it is, an attacker has easy access to knowing the password and using it. Now, why does it matter? Well, authentication is the gateway to everything inside the app. If an attacker can break in or pretend to be someone else, they can steal the data, perform unauthorized action, spread through the system undetected. This phase helps stop identity theft, account takeover, and privilege abuse. Now, hence, from a vulnerability management perspective, authentication flaws are high risk vulnerabilities and must be identified, prioritized, and fixed fast. This phase supports the identify, protect, and respond function in the NIST CSF. Strong authentication reduces the chance of successful exploit even if other flaws exist. Hence, in summary, the identity and authentication testing phase checks if the apps know who the user really is and protect that identity through secure login, secure password, a strong password, and session control, also with multi-factor authentication. It's about making sure only the right people get in and no one else does. The fourth part of the life cycle is authorization and session testing. In simple language, this phase focuses on two important questions. Can user access only what they are allowed to, which is actually authorization, and are users login session managed securely, which is actually session management. In simple terms, it checks if users can see or do things they shouldn't, and whether session controls like cookies and timeout is safe and reliable. So, what is this authorization testing? Well, authorization is about permissions. What user is allowed to access or do. This testing checks, can a regular user access admin only page? This test, can a user see or change other user data by tweaking the URL or form fields? This testing also checks whether are these access control gaps or are there access control gaps that the attacker could exploit. The intent here is, in summary, to ensure that app follows the need to know and need to do principle. So, what is session management testing? Well, session management controls how long a user stays logged in and how their identity is tracked during that time, often using a session cookie or token example. This testing checks, are session IDs unique, long, and hard to guess? Are sessions terminated after logout or inactivity? Can sessions be hijacked or reused? Are cookies secure, HTTP only, and encrypted? Well, this ensures that attacker can't steal or reuse someone else's login sessions. This is session management testing. Well, common vulnerability that are tested at this phases are broken access control, which if it is, then user can access data or function they shouldn't. It also tests insecure session ID generation, which means if it is, then attacker can guess or brute force a valid session token. It also tests for session fixation, where if the gap is, the attacker forces users to use a preset session ID. It also tests for missing logout or inactivity timeouts, where if it is the case, the session stays open too long, increasing hijack risk. It also tests for unrestricted file access, where if it is the case, then sensitive files can be viewed directly via path change. Now, from a vulnerability management perspective, authorization issues are critical and can lead to data leaks, unauthorized changes, or privilege escalation. Session flaws open doors for attackers to impersonate users. These vulnerabilities should be identified, risk rated, and remediated quickly as part of the detect, protect, and respond phase of NIST CSF. Hence, in summary, the authorization and session testing phase ensures that the user can only access what they are supposed to and that the login sessions are managed securely. It's about keeping users in their lane and making sure no one else can sneak into their seat. I hope this gives a better insight on this part. The next is input validation and error handling. Well, this phase checks how the application handles user inputs and what happens when something goes wrong. In simple terms, it asks two questions. First, can users send harmful inputs that breaks or tricks the system? Does the app leak information when an error occurs? Now, what is this input validation? Well, whenever a user types something to a website or into a website, like a name, email, or search term, it's called as input. Input validation is how the app checks if that input is the correct format and safe. The correct format example is a proper email. Safe is not a command or a code. This testing looks for injection attacks like SQL injection or command injection. This testing looks for cross-site scripting where harmful code run into the browsers. This testing looks for bypassing filters or form restrictions. This testing also looks for are they uploading dangerous files like the exes or any script. Now, good validation blocks bad input before it can cause a harm. That's the objective of this pillar on input validation. Now, why input validation fails? Well, if the app trusts user input without checking it, or filters can be weak, missing, or easy to bypass, or developer forgot to validate input on the server side. These are the places where input validation can fail or fail actually. Now, what's the other part? What's error handling? Well, when something goes wrong, like a crash or a failed login, the app should show a generic error, like something went wrong. But poorly designed app may show detailed error messages, might reveal server path, file names, or database errors, or include code snippets or debug info. Now, good error handling hides the internal details from users and attackers. Now, in this, think through how many times have you seen a website throw an error which is just not stating that site down or so, but gives you a long sentence, and that's an indication of bad error handling. Now, this is a place to feed for any attacker. If you are new to hacking or you are a script kiddie or anyone, these are feeding points. When an error shows up and it is not generic but gives you a lot of other gibberish for a layman, but it is not so for an attacker, that's good enough a good entry point. Attackers would feed onto that, jump onto it whenever a website throws these type of messages. Now you know what this is. What is the importance of error handling? Think through. Next time you see an error coming up popped on the screen, which is a long sentence, a statement, and gibberish one. Well, it's not gibberish. It is indicating a poor error handling of the application and a feeding ground for attackers. Now, what does this phase test? Well, it tests input validation, wherein it checks can the attacker inject harmful data, special characters in forms, wherein do they use crash, leaks, and security issues? Do they cause that? File upload, it tests that. Can dangerous file be uploaded? Error message, do they reveal too much about the system? This is something which we discussed just now. Debugging features, are debugging tools or models left turned on? From a vulnerability management perspective, these are common and high impact vulnerabilities, especially in user facing application. They support the detect, protect, and respond phase of NIST CSF. Catching them early prevents data leaks, unauthorized access, and code execution risk. In summary, the input, validation, and error handling phase test whether the app checks inputs safely and handles error securely. It helps ensure attacker can't send a dangerous command or learn too much when something goes wrong. The next is business logic and client side testing. Well, in this phase, the focus is on how the application behaves, both in its core business process and in what runs in the user's browser. In simple terms, it checks if attacker can misuse the app logic or tamper with what runs on the user's screen. This starts with business logic testing. Well, every application has rules, the logic that makes it work. For example, a user can only transfer money they own. Coupon cannot be used more than once. Discount shouldn't be more than 50%. Well, business logic testing looks at whether an attacker can break or abuse these rules, like reusing a discount code, like skipping steps in a process, like paying without completing the checkout, modifying the value, example price, quantity, through hidden forms field in or URLs, or changing account type by guessing the URL. Well, it's about testing how an attacker could trick the app by thinking differently, not by using technical exploit but by manipulating the flow. I hope you understand now the business logic testing that goes in. From a client side testing perspective, client side means what runs on the user's browser, like JavaScript, cookies, and the document object model or DOM. Now, this testing checks is the browser exposing sensitive data, example like via JavaScript. Can someone tamper with the JavaScript to change the price or bypass the check? Well, this testing checks are cookies secure, HTTP only and not easy to steal, or is the app vulnerable to cross-site scripting, or are third-party scripts safe and trusted? Well, it's about making sure the app doesn't trust the browser too much and that it defends against attack that starts from the user side. In this phase, what it looks for is, or rather tests is, broken business logic. Well, if there is, then user bypasses payment or perform actions out of order. It checks for parameter tampering. This, if this is true, then user can change hidden field to get unauthorized benefits. It also tests for insecure JavaScript, where if it is the case, then malicious script could steal sessions, tokens, or inputs. It checks for unprotected cookies, wherein if it is true, then attacker can steal or replay user sessions. It checks for DOM-based XSS, which if it is true, then malicious code injected into a browser is possible. Now, from a vulnerability management perspective, these flaws often won't show up in automated scan. They require manual, intelligent testing. Business logic issues are high impact because they break the core trust in how the app works. Client-side flaws expose users to fraud, data theft, and session hijacking. These risks map to detect, protect, and respond phase in the NIST CSF. In summary, the business logic and client-side testing phase checks if the app can be tricked or misused and whether what runs in the browser is safe and secure. It protects both the organization's rules and the user's experience from silent creative attack. I hope this helps with this vertical on business logic and client-side testing. The next is the API and web service testing. Well, this phase focuses on testing the application programming interface or APIs and web services that connects app systems and users in the background. In simple terms, it checks if the backend highway of your app, the APIs, are secure, they don't expose sensitive data, and can't be misused by attackers. So, what is an API? Well, API or application programming interface is a way for apps to talk to each other, mobile apps to connect with servers, website to exchange data behind the scene. Example, when a mobile banking app shows you your account balance, it is using an API. When an e-commerce site fetches the product detail, it is calling an API. Well, APIs are powerful and a big target for attackers. So, what does API testing looks for? Well, it tests authentication and authorization. It's important because can user access only their own data or via the API? That is what it checks for. Under rate limiting, it checks can an attacker overload the system or brute force any action. It tests for data exposure, wherein does the API return sensitive information like password, tokens, or internal ID. That's what is tested at data exposure. It checks for input validation, wherein they check can the attacker send bad or harmful data, like injecting attacks. It checks for broken object level authorization, which is can an user access someone else's record by changing an ID? Is it possible? It checks for error handling, which is does the API reveal system details when something fails? Well, this ensures API only gives the right data to the right people in the right way. Well, common issues in insecure APIs. Well, it exposes admin level endpoint. It can. The other issues with AP insecure APIs are lack of authentication or weak tokens. Mass assignment where attacker changes restricted field. APIs that trust the client too much. Verbose error message exposing internal logics. These are common issues in insecure APIs. Now, from a vulnerability management perspective, APIs are often missed in traditional scans. So they require dedicated testings. OWASP also has a separate OWASP API security top 10, which maps risks specific to APIs. API testing supports the detect, protect, and respond function in the NIST CSF and is critical in cloud native and mobile heavy environments. Hence, in summary, the API and web service testing phase focuses on invisible backend systems that connects users to data. It ensures API don't leak information, trust users too much, or allow attackers to sneak through the cracks. I hope these 7 life cycle areas are clearer or better understood. You can rerun this video again if you want to do a refresh and take notes. Mapping OWASP testing to the VM lifecycle. Well, the OWASP testing guide helps identify application level vulnerabilities, while the VM lifecycle is the broader process of finding, fixing, and improving security gaps across all systems. When used together, they complement each other. The testing guide helps with what to test, and the VM lifecycle helps what to do next. So, one is what to test, and one is what to do next. Let's break down how they map together. Let's look at identify. Well, what it means in VM. Building an inventory asset and understanding what needs protection. That's from VM perspective. What's OWASP's contribution? Well, it contributes by information gathering phase, helps discover hidden pages, expose APIs, forgotten endpoints, and technologies in use. It contributes by revealing the attack surface, everything that could be tested or exploited. When we look at detect, from a VN, it means run scans and test to discover known and unknown vulnerabilities. From an OWASP perspective, the core testing phase, which is authentication, authorization, input validation, business logic, API testings, help manually or semi-automatically detect real-world flaws in the app's behavior, design, and logic. From a client side and error handling test, it also detects weakness missed by traditional scanner. The OWASP shines in this phase by going deeper than an automated tool. When it comes to prioritize, from a VM perspective, ranks vulnerabilities based on business impact, exploitability, and exposure. When it comes to OWASP, how does it contribute? Well, many of the tests in OWASP simulates real attacks, showing how dangerous a flaw really is. It helps team recognize high-risk flaws like broken access control or sensitive data exposure. Can be aligned with risk scoring methods like CVSS or contextual analysis. Under the remediate phase, from a VM perspective, it fixes the issue, patches the code, updates the configuration, or apply compensating control. But when it comes to OWASP, each testing phase includes remediation tips, secure coding guidelines, and links to fix. Developer can use this information to write secure code and avoid reintroducing the flaws. Under the improve phase, from a VM perspective, it learns from past issues, enhances process, and raises the security maturity level. From an OWASP perspective, it helps build secure development practices by educating developers and testers. It offers reusable tools like the ASVS, which is Application Security Verification Standards, and OSAW's Top 10 as a benchmarks are used. It encourages continuous improvement, not one-time fix. I hope you understand now the summary, which is identify in VM is equal to information gathering and threat modeling in OWASP. In VM it is detect, in OWS is all core test, logics, client side testing, etc. When it comes to prioritize, it is using business logic, insight, risk awards, severity, using the top 10 references of OWASP. When it comes to remediate, it's fixing recommendations, secure coding tips. When it comes to improve, it is about the top 10 developer training, repeatable testing models. And a final thought, OWASP testing guide helps you find vulnerabilities with precision, while the VM lifecycle ensures you track, fix, and learn from them. Together, they build a stronger, smarter, and more secure application ecosystem. DevSecOps stands for Development, Security, and Operations, working together to build secure software from the very beginning. In simple terms, DevSecOps is about baking security into every stage of software development, not sprinkling it on at the end. The OWASP testing guide fits perfectly into this model by providing practical security tests and checks that can be used throughout the development lifecycle. So, why DevSecOps needs OWASP testing? Well, traditional security testing often happen after development, which is too late, more expensive, often ignored under release pressure. By using the OWASP testing guide during DevSecOps, teams can catch the issues early on, fix problems faster, build security into code, design, and processes. So, how does OWASP testing fits into the DevSecOps stages? Well, if you look at from that side, the plan and the design part stages of DevSecOps, in this, the OWASP testing uses the top 10 and ASVs to define secure coding and design requirement. At the development stage, it trains developers using the guide's test cases. When it is build phase of the stage, OWASP integrates basic security checks into the CI/CD pipeline. When it is the test stage, it runs manual and automated tests from the OWASP testing guide. When it is release stage, it's where it validates key controls, which is session management, business logic, before the launch. When the stage is operate and monitor in DevSecOps, the the OWASP testing helps to monitor exposed APIs, misconfiguration, and client-side risk. When it's feedback and improve, the testing from OWASP helps to test results to improve development practices and automate remediation. Example of OWASP used in DevSecOps space. Well, during coding, developer use OWASP inputs validation, example to prevent cross-scripting or SQL injection. During testing, the quality analyst and the security team test login flows and API endpoints using OWASP's authentication and API testing guide. During release, pipelines trigger automated tests for exposed files, default settings, or broken access control. And after deployment, client side and configuration testing helps catch issues left behind or added during deployment. Now, what's the benefit of integrating OWASP in DevSecOps? Well, shifts security left earlier in the life cycle. It reduces the cost of fixing the bug. It improves collaboration between teams like DevSec and operations. It enables automated, repeatable security checks, and it builds security culture into everyday work. In summary, the OWASP testing guide is a practical toolkit that fits naturally into the DevSecOps process, helping team build secure code, test it continuously, and improve security with every release. You can pause the screen and look at the workflow and take notes on what I have mentioned earlier on the details and the aspects of it. I hope this helps you build your own checklist. You can take this as it's in itself, or you can build on it based on your specific business cases. The next aspect is reporting and risk metrics based on OWASP. Well, once security testing is done, whether manually or using automated tool, the next step is just as important. Reporting the results clearly and measuring the risk so the right people can fix what matters most. The OWASP testing guide helps not only in finding vulnerabilities but also in communicating their impact effectively through structured reporting and risk metrics. Now, what is reporting in security testing? Well, reporting means putting together the findings of a security test in a way that is easy to understand, highlight what's at risk, explain what to fix first, and support decision making by developer, manager, and leadership. So, what a good OWSP backed report should include? It should include the executive summary, which is a high level overview for management, main risk, impact, and recommendation action. It should include the finding list, which is a detailed list of vulnerabilities found during the testing. It should also include risk rating, which is severity level, low, high, medium, criticality, based on the OWSP risk model. It should include the technical details, which is the URL, the test case, the payload, the affected components, the screenshots, if any. It should then include remediation guidelines, wherein we suggest the fixes, the references from OWSP, and the secure coding best practices. The last and important, the prioritization table should be there as part of the summary, which is helps the team fix the most dangerous issues first. So, what are the risk metrics? Well, risk metrics are used to measure how serious each vulnerability is. How many issues were found over time? Which type of flaws occur more often? Whether security is improving release after release? Well, OWASP based metrics you can use for example, track common risk like injection or access control, measure response speed and accountability, track how long a critical issue stayed unresolved, measure if fixes were done correctly or are recurring, indicate how well dev teams understand secure practices, flow workflows, help assess exposures to front end based attacks. These are the metrics you can use. So, how does OWASP helps prioritize the risk? Well, it recommends using a risk rating model based on likelihood, which is how easy it is to exploit. It's also based on impact, which is what happens if it is exploited, and business context. What's the value of the affected assets? This helps team focus on what really matters, not just fix everything blindly. In summary, reporting and metrics turn testing results into actionable insight. The OWASP testing guide helps security team not only find issues but also explain them clearly, rate their risk and track progress over time. It ensures that technical findings lead to business aligned decisions. So, security becomes a measurable, managed process. Let's look at the regulatory alignment and audit readiness perspective. Well, security isn't just about fixing bugs. Organization also need to meet regulatory requirement and be ready for audits. OWASP helps team build secure application in ways that aligns with laws, standards and audit checklist. What does regulatory alignment mean? Well, it means making sure your application security practices match what regulators expect, such as data privacy or information security standards or industry specific regulations. These laws and framework asks questions like, do you test your web application for security? Do you protect sensitive data from unauthorized access? Do you follow a secure development life cycle? Well, the OWASP testing guide helps you say yes with confidence by showing your testing approach is structured and complete. So, how does OWASP helps with audit readiness? Well, when the auditor comes in, they want to see policies and procedures for testing, testing evidence, which is screenshot, report, logs, how risks are rated and addressed, and how secure coding is enforced. Now, here OWASP provides a structured testing methodology, a clear focus on the most critical vulnerabilities, a guidance aligned with best practices in NIST, CSF, ISO 27000, PCI DSS, and others. It provides mapped standards like the OWASP ASPS for control verification and SAMM for maturity. Well, a sample OWS regulatory mapping would look like input validation. It can be mapped to ISO 27001 and PCI DSS. For authentication and session, it can be mapped to the NIST 800 or GDPR Article 32. From a secure configuration checks, CSI benchmarks ISO 27001 sections. API security testing, well, it comes through the OSAW API top 10, aligns with cloud and data privacy laws. From a business logic testing perspective, support risk assessment in SOC 2 and ISO audit. Well, these alignment gives you an audit ready evidence that your application has been tested in a matured and structured way. Well, OWASP isn't just about finding bugs. It's a framework that helps prove your application are tested and secure in a way that meets global regulations, frameworks, and audits. It helps teams stay compliant, confident, and ready for scrutiny while building more secure softwares. Let's look at challenges and remediation strategy. Here is a screen which gives you certain aspects of the challenge. Well, in simple language, the OWASP testing guide is powerful, but using it effectively comes with a few common challenges. The good news is each challenge has a practical solution. The first is, can say, not enough skilled people to run the test. Means it lacks security testers who understand web apps deeply. The remediation, train developers and QA team on OWS basics. Use OWS juice shops or WebGoat as practice labs. Start with simpler, high impact tests and scale up over time. Second is the manual testing takes time. Well, the testing guide is detailed and full testing can be slow and effort intensive. Well, remediation is focus on critical test first. Automate wherever possible using tools. We have Zap, Burp Suite, or custom scripts. Combine automated and manual testing for a balanced approach. The next challenge is testing happens too late. Well, if testing is left until after development, it's harder and costlier to fix it. Remediation is integrate your OWASP based checks into the DevSecOps pipelines. Use pre-commit hooks. Use and unit test for security logic. Make testing a part of development and not an afterthought. The next challenge is no risk based prioritization. Well, not all findings are equal, but without a system, team can fix low risk issue first. Well, the remediation, apply CVSS, VPR, or OWASP risk rating model. Prioritize based on likelihood and business impact. Use dashboard to flag critical and high findings for immediate actions. Well, next challenge is custom business logic is often ignored. Well, tools can detect logic flaws, and these are often missed entirely. Remediation, include manual testers for business flow testing. Review user stories and workflows to identify misuse path. Involve product teams in scenario based risk review. The next challenge is lack of standardized testing across teams. Well, different teams may test differently or not at all. Yeah, remediation, adopt the testing guide as your standard methodology. Use checklist as shared playbook across development and quality. Integrate with company-wide security policies and SDLC template. The next challenge is no evidence for audit or compliance. Well, if findings aren't documented properly, it's hard to show auditors you tested at all. Well, remediation, create a repeatable report template based on OWASP. Log findings with screenshot, affected URL, payroll, and severities. Tag issues with regulatory mapping when possible. The next challenge is security fatigue or pushback from dev teams. Yes, developer may see testing as extra work or slowdowns. Remediation, use the OWASP to show real attack examples. Provide actionable, respectful feedback with clear fixes. Shift from blame to collaboration. We are building secure app together. Now, that should give you a context. While I have explained 8, I've shown the top 5. So you can use this as a reference. So you start off with this 5 and then you can move ahead with the rest of the items. I hope this helps you with a better context. Now, what you see is a testing guide for risk mapping. You can take a screenshot of this and you can figure out which one works for you and your business environment. Now we move on to the checklist way of working. Let's start off with a sequence. So this could be a flow that you can use, or you can use this as a reference and build your own checklist. But this could be a good start point, I hope. So maintain a documented application security testing policy. Then move to use the OWASP testing guide as your formal testing methodology. Conduct regular tests for the OWASP top 10 vulnerabilities. Include authentication and session management test. And perform input validation and output encoding test. Then check for access control, authorization weaknesses. Test for API vulnerabilities using OWASP API testing guidelines. Then include business logic testing in your assessment. Ensure secure configuration and deployment management testing. Test for secure client-side controls, which is cookies, JS, DOM, this risk. Document findings, risk levels and remediation plan. Track time to remediation, especially for critical and high-risk findings. Maintain testing evidence, which includes screenshot, payload, logs for at least 1 year. Integrate OWASP's based testing into DevSecOps pipeline. Align findings with ASVS or SAMM maturity model. Optional but recommended. So how to use this checklist? Well, use it to prepare for audit involving application security. Here is the workflow in a checklist and purpose and the map standards for your reference. So use the checklist to prepare for audit. Map the testing output from the OWASP testing guide to controls in 27001, PCI DSS or SOC 2. Map it out. Because if you're already 27001 compliant, PCI DSS compliant, SOC 2 compliant, this would add value to it. Pair it with dashboard or metrics report showing risk trends, coverage and response time. Review and update it quarterly or with every major release. I'll pause here, think through what you have just understood. See if this helps you with your strategy and your planning. Important immediate low-hanging fruit would be taking this workflow and running with this. And as you move, you can enhance and refine. You can knock things which might not be relevant in case that is it. But generally, these are the steps which would be used or applicable across. In conclusion, the OWASP testing guide offers a highly structured, actionable, and industry recognized methodology for identifying application vulnerabilities. From a vulnerability management perspective, it extends visibility deep into the application layer, covering everything from misconfiguration and broken access controls to business logic flaws and insecure APIs. By integrating OTG into the VM lifecycle, organizations not only improve their security posture but also enhances compliance, reduces operational risk, and build common trust. Whether used by red team, DevOps, or DevSecOps pipeline, or security auditors, OWSP testing guides is essential to any mature VM program. With this, we have covered the original agenda of part 3 of OWSP testing guide. Do remember this is from a vulnerability management perspective, and this is part 3 of this series. So we have one more part to go. We'll cover the next aspect of it. So I hope this has been useful, productive for you. If you think this has helped you, do like, subscribe. Important here is to think through your colleagues, your friends, or anyone you think wants to enter this territory of vulnerability management or OWASP testing guides. Do share it with them so they can also benefit. They can learn, they can develop, they can enrich this and help the organization they are with. The whole idea behind this is to simplify as much as possible the complex world. It can be overwhelming. Vulnerability management is a space, a specialized space. You'll have an army of people trying to manage the show and still struggling. That's because of the nature of the space. These videos are there to help them in some way, ease the pressure that they are in, get a direction for them so they can crack the code. I hope this helped them or you in some way. Again, do help subscribe if this has helped you. Thank you very much for the time that you have invested. While we'll see you in part 4, we'll end this part 3. This is your host, Savit Vittal Salian. I would like to thank my mentor, Sri Ganapati, and Mr. Mahakai for providing the direction in this space. Thanking all. Namaskaram.